Okay, everybody. So what we're going to talk about here is the most efficient way of counting to figure these probabilities out. So with one die, it's actually pretty simple to see why the chance of getting a 5 is 1 in 6, because there's 6 sides and only one of them's a 5. And if you roll this thing over and over and over and over again, 1/6 of the time it's going to end up on 5. The reason I included that column D in the spreadsheet was because when you start getting more than one die going, like for example, if you have 2, the chance of figuring out how many ways to roll a 5 is actually harder than to figure out the number of ways to not roll a 5. And that sounds a little bit weird until you think about it. Think with just 2 dice. How many ways can you roll a 5? Well, the red one can be a 5, and this little smoky one can be not a 5. The smoky one could be a 5, and the red one could not be a 5, or they both could be a 5. That's 3 different situations you have to account for. And it gets even crazier when you have 5 dice. Let's get that one to be a different color. So if you have 5 dice, if you think about all the ways you can have 5s, you could have exactly 1 5 on all the dice. And then it could be that 5, or it could be that 5, or it could be that 5, or it could be this 5, or it could be this 5 over here. Or you could have 2 5s and 3 that aren't, but then you have those 2 5s, or maybe you have these 2 5s, or maybe you have, and you see it's getting ridiculous already. You could have 3 5s and 2 not. You could have 4 5s or 2 not, and you could have 5 5s or 2 not, and it just gets ridiculous the more dice you have. I mean, if you end up with a whole bunch like this, the possibilities of having 5s are actually, it gets kind of mind-boggling. So it's too hard to keep track of how many ways to get the 5s. So what statisticians have figured out, it's pretty clever actually, is just figure out the ways to not have 5s. So in other words, there's all those goofy ways to have 5s on all these dice. But it's actually really simple. How many ways can you not have 5s? Well, there's 6 sides on a die, right? 5 of them are not 5s. So there's 5 ways for that die to fall right there and not be a 5. There's also 5 ways for that die to fall. And 5 for that, and 5 for that, and 5 for that, and 5 for that, and 5 for any number of dice. 5 for any number of dice that won't be a 5, or any other number for that matter, but we're using 5 in this particular example. And then, once you've figured out how many ways the 5s can't show up, and you know the total number of ways that all these dice can be rolled from all the fundamental counting principle stuff we've done, then you can figure out whatever's left over. Because if you have the total, and you know that this many ways there can't be any 5s, that means if you subtract them, you end up with the ways there can be. And that's where columns D and E come together, which is why they add up to 100%. If a certain percent doesn't have 5s, whatever's left has to have 5s. Cool? Hope that makes sense. We'll see you in class.